Good morning, students. Today we are going to do some numericals based on the dimensional analysis. Whatever the applications of dimensional analysis we had studied till now, on the basis of that, we are going to discuss some numericals, and after that, we will discuss about the limitations on dimensional analysis. So, a very good question in front of you. If 1 horsepower is equal to 746 watt, then comment on the statement 1 horsepower is equal to 550 foot pound per second. Means it is the commercial unit of power, that is horsepower, which is equal to 746 watt, and you have to convert it into British system of unit, that is foot pound second system of unit. So look at here how we are solving it. You know that horsepower is unit of what? It is the unit of power. All of you are knowing that. And the dimensional formula is, its dimensional formula, dimensional formula, that is equal to power, work done per unit time. The work done per unit time means work done is ml square t minus 2 upon time, ml square t minus 3. This is the dimensional formula for power. 1 horsepower can be written as 746 watt, and it is equal to 746 kg meter square second cube. Now, for your knowledge, I am saying that 1 pound is denoted by LB. 1 pound is equal to 0.4536 kg, or you can say that 1 kg is equal to 2.436 pound. 1 kg is equal to 2.436 pound. So from there we had find 1 pound is equal to 0.4536 kg, and 1 foot is equal to 0.3048 meter. Now, as we had seen in our discussion, for the conversion of one system of unit into other system of unit, so we have to put the values of 1 pound. 1 HP is equal to 746 kg meter square. So we have to put in the form of LB 1 upon 0.436 LB and 1 upon 0.3048 foot square. So we are solving it. Look at here. So in other system of unit we can write it as 1 HP is equal to 746 1 upon 0.4536 LB, that is pound, and 1.03048 foot square upon second cube. So on solving it, 1 HP is equal to 746 into, on solving this thing and after multiplication we will get 23.73 LB, pound foot square per second cube. And from here 1 HP is equal to 1772.55 LB foot square per second cube. Now there is a relationship between foot pound second and pound foot square second cube. So I am writing here in 1 pond foot square upon second cube. It is equal to 32.2 foot poundal per second. So 1 HP can be written as 17702.55 upon 32.2 FT pound per second. And on solving this we will get the value. On solving this we will get the value. 1 HP is equal to 550 foot pound per second. 1 HP is equal to 550 foot pound per second. So this is a good question, and it is the conversion of HP into foot pound second. Now the next question. Look at the next question. The next question is, next is example. A gas bubble from an explosion under water. A gas bubble from an explosion under water oscillates with a period t proportional to p to the power a, d to the power b, and e to the power c, where p is what? P is static pressure, d is density of water, and E is total energy of explosion. Total energy of explosion. So you have to find the value of A, B, C. What we have to do? We have to find the value of A, B, and C is equal to what? So it is very much simple, that it is given that the gas bubble time period. What is the time period of oscillation of the gas bubble on explosion is dependent on P power A, that is pressure ka power A, density ka power B, and total energy ka power C. So we have to calculate the value of, you are knowing the formula, dimensional formula for pressure, density, and energy. Put their values and then equate by the principle of homogeneity with the time, and from there solving the equation you can get the value of A, B, C. So very much simple. I am doing it. Look at here. Given that answer T is proportional to P to the power A, D to the power B, and E to the power C. Putting the values, T is the time period, T, that is pressure, ml minus 1 T minus 2 power A, density L minus 3 power B, and energy M L square T minus 2 power C. It is equal to M0 L0 T, that is equal to M A plus B plus C, L minus A minus 3B plus 2C, and T minus 2A minus 2C, minus 2A minus 2C. On solving it, now by the principle of homogeneity the dimensions are equal. Since it is based on the principle of homogeneity, so obviously by the principle of homogeneity the dimensions will be same. So A plus B plus C is equal to 0, minus A minus 3B plus 2C is equal to 0, and minus 2A minus 2C is equal to 1. Now solving these equations for A, B, C. So on solving it for the values A, B, C, on solving it, we are getting the value A is equal to minus 5 by 6, B is equal to 1 by 2, and C is equal to 1 by 3. A is equal to minus 5 by 6, B is equal to 1 by 2, and C is equal to 1 by 3. So by putting these values in the above formula, so we will get T is equal to K P minus 5 by 6, D 1 by 2, and E 1 by 3. And from here we will get the formula under root D cube root E upon 6th root P to the power 5. And this is the time period for oscillation of the bubble. Now the next question. If velocity, force and time are taken to be the fundamental quantities, if velocity, force and time are taken to be fundamental quantities, find the dimensional formula. Find the dimensional formula for A mass and B energy. We have to find the dimensional formula for mass and energy if velocity, force, time is taken as the fundamental quantity. They are considered as the fundamental quantities. So we have to find the value of mass and energy. Now we are going to solve this question. Let that physical quantity be at supposed Q, and it is proportional to the function of dimensional formula velocity, force and time t. Velocity, force and time t. So Q is equal to proportional to K, V to the power x, F to the power y and T to the power z. So dimensional formula for q can be written as k v l t minus 1 power x, force mlt minus 2 power y, and time t power z. Clear? On solving it, q that is equal to k and mass power y l x plus y and t minus x minus 2y plus z. Clear? This is the relationship with the dependent variables. We had shown the relationship. Now, first of all, in section A we are considering it as mass, and in the second section we are considering q as energy, and then finding the value of x and y for both the cases. So for case A, q is equal to what? Mass. Q is considered as mass. So m that is equal to m power y, l power x plus y, and t power minus x minus 2y plus z. Obviously, by the principle of homogeneity, y is equal to 1, x plus y, because here there is no any term for length, so x plus y is equal to 0, and t minus x minus 2y plus z is equal to 0. On solving it for x, y and z, x is equal to minus 1, y is equal to